Alright, so let's get started here. Go ahead and download Unity at unity3d.com and hit the download button. I'm going to be using Unity 4.6.2 free version for this. For the complexity of our program, any future version will work, and even some in the past up to a certain point, so don't really worry about it, just get the latest version if you can. So once that's downloaded and installed, go ahead and open up Unity. Go ahead and make a new project here. And call it tutorial game. Select that folder. We're not going to need any of these packages right now. We're doing some pretty basic stuff, so we're not going to need anything too fancy. Go ahead and hit create and let Unity open here. Alright, so depending on your layout, Unity might look a little bit different from what my window looks like. You might have the same windows just in different locations. You can change your layout by hitting this layout button in the top right corner. And mine is a slightly modified version of the wide setting, and you can pull these windows everywhere you want. So my setup is just I have the scene here and I have my game window here. It's a nice little balance, and I have my hierarchy and project at the bottom. So once you're all set up the way you want, let's go ahead and get started with moving this camera out of the way. Let's go ahead and zero out this camera. Go to your transform in your inspector after selecting this camera. Go ahead and zero out all of your options. You can leave the scale here because it doesn't really apply to a camera because you can't really transform a camera like that. But for now, that's okay. So we're gonna need a floor here. Nice and basic. We're not gonna need anything too fancy. Let's go ahead and go to game object, create 3D object. Let's go ahead and make a plane. Let's zero out this plane just so it's easy to manage. Let's go ahead and go to the scale option in our transform, and this is just going to make our plane a little bit bigger on the different dimensions. So we can hit, let's go with 20 on the X, and you don't need to modify the Y because this is a plane and it doesn't move in that dimension. Let's go ahead and hit 20 on Z. So 20 by 20 plane, centered out, perfect. Now, if we lift our camera up a little bit, you'll see the plane render. It's this big gray open spot, and yeah, it's looking really, really dark. So, to alleviate that, let's go ahead and go to Game Object, go to Light. Let's plop a directional light in there. And you notice everything lights up. I'm gonna just zero out this light right here. With the directional light, it doesn't really matter because honestly it just floods the entire world with a huge white light. So you can put it anywhere you want, honestly. I'm just gonna get it zeroed out and out of the way here. Alright, perfect. Okay, so now we have this big open playing field to start creating. Go ahead and go to Game Object, create 3D Object, Cube. And we're gonna start building our walls here. I'm going to head and zero out this cube one more time, just so we can have a nice center point here, reference from it. Let's say, I'm going to set X to 2, and let's start stretching this out a little bit. 5 on the Z scale, seems pretty nice. Alright, a useful keyboard shortcut for duplicating objects in Unity is Control D. So as long as you have the object selected, hit Control and D, and you'll have a duplicate right there. And since we want this somewhat even, we can just go ahead and hit -2. So that'll go across the origin point to the opposite coordinate. Perfect. And then I'm going to go ahead and select both of these by holding the Shift key and raise them up a little bit. I'm going to raise them by 0.5 on the Y. Alright, that's looking good. So we have some basic walls here. Let's go ahead and make one more wall and cap off the end here. So I'm going to select one of these and hit Control D again. Now I'm going to go to my rotate tool. Rotate these about 90 degrees on the Y axis. Alright, cool. So you notice it's a little wonky here. You see it's put the rotation into the gizmo and it looks a little off center here. So moving around like this, yeah, that's not going to be fun. So what we can do to fix one of these problems is instead of being in local rotation mode, we can go back to global rotation mode by hitting this little button right here. You'll notice the little pivot goes back to where it should be. Cool. So another nice little tip here is you can hold down the V key and snap vertices. Yeah. So that allows you to get that nice clean edge right there. Nice and perfect. Now I've noticed a little issue here. Right now it's not too significant. However, in the future of our little development here, we're going to need this blue arrow to be facing north. So what we can do is we can hold hold the shift key and select all of our cubes here. And then go ahead and rotate them. Uh-oh. That's not good. Okay, well, here's what we can do. Since these are all going to be grouped together anyway as walls, go ahead and select all of them, and then while hovering in your scene view, hit F, and you'll have your camera focus on all of them on their center point. Go ahead and go to hit Game Object, Create Empty. Let's just call this Walls. Now, go ahead and hit Q. Let's put that in our Walls game object. And you can have these all selected at once and just call them Wall, just so it doesn't have a bunch of cubes. Now, these walls are now a child of this empty walls object. So now our center point is actually here, and we can actually rotate that freely. So let's go ahead and rotate that 9 degrees. So we should, yep, we have our blue arrow pointing north here. That's perfect. And I'll explain why that's useful in a minute here, once we start making our player. But let's get our walls a little bit decorated, because we're going to have a top-down view here, and having everything white, you won't be able to see anything but some dim shadows. So let's go ahead and make a new folder here. Create new folder. Let's call it materials. Go ahead and go in that folder. And let's create a new material. And this is basically just a little shader that we can put on objects and color them. I'm going to call this wall. And this will be our wall color. I'm going to pick kind of a dark green. You can change the color by going in your inspector while this is selected and hitting main color. And you can click in this little box right here, the color picker, and you can pick any color you want. But I'm just going to go with the dark green for now. Now, once you have your color selected, you can go ahead and left click and drag and put it on any object you want. Alright, so now we have nice green walls. So now we're going to need to make a little player to roam around our letter U. Perfect. So let's go ahead and make one more cube. Game object, create 3D object, cube. Oh yeah. Most intimidating protagonist ever. Okay, so this is just a blank little cube. He doesn't do much, but with the power of programming in C#, we're going to make him into a video game character. So first things first, let's get this kind of centered a little bit. Alright, that's looking okay. I'm going to set his Y to 0.5. The reason we're going to do this is because we're going to be using a movement system, and we want him, actually no, not 0.5, let's say 0.55. We want him slightly above the ground, so when he spawns, he doesn't clip through the ground and immediately fall to his death. That would be bad, and that would not be a fun game to play. So once you got that all set up, his position doesn't exactly matter too much, but you kind of want him in the center of the starting area, just, you know, just to keep following along here. So first thing that we need to do is let's name him player, so we know who he is. And since this is going to be a top-down game, we're going to need the camera to move with the player. Now, there's no scripting involved with this. We're going to be using something called making a child object and using a parent object. So basically what this is going to do is we're going to make it so this camera will inherit the transform of this player. So what you can do is in your hierarchy, you can select your camera and then drag him on to the player. Now this camera is inheriting its parent transform. So if I move this cube around, the camera moves too. The camera is not looking at the player right now. So we can go ahead and zero it out, because remember, it's inheriting the player's transform information. So 0, 0, 0 is no longer the center of the world map, it's the center of the parent object. Let's go ahead and rotate this 90 degrees. Lift them up a little bit. I'm going to say 5 sounds good. And on the X, we're going to put 90 degrees, so we're looking straight down. Now you can't see the character right now because, like I said before, if you have white on white, you will not see anything. So let's go ahead and make a new material here. Right click, create, material. Let's call him player. I'm going to make him maybe a sky blue color. It'll contrast on white nicely. All right, cool. So now we can easily see our player. Now, if we hit play, nothing's going to happen. He doesn't have any programming. If we hit WASD, nothing happens because we're not telling the computer to do anything. It's just rendering a cube and a couple shapes. So what we need to do first is, let's go ahead and hit add component. And it's already typed out here, but you can say RI, and you'll see rigid body here as a first thing. Go ahead and click that. And that's going to allow our cube to have a little bit of physics going on. So if I kind of zoom in a little bit, and I hit play, you'll see it fall, that 0.5. Bonk. Yeah, that was exciting. Now that we have a little bit of physics going on, we're going to need to constrain this rotation here. So go ahead and go to this little arrow at the bottom. Hit freeze rotation on X, Y, and Z. And I'll explain this in a little bit once we start programming. Okay. Now it seems that this player has a different this player seems to have a different idea of what forward is, so that's okay. We can change our walls. Yep, that makes sense. Okay, that was my bad. I changed the direction of the walls because it was in the local rotation, and I thought this Z position was facing north. Turns out it wasn't, it was in local, so messed that a little bit. We need a global north going on here. So what we can do is pivot this. See how this says 90? Just go ahead and set that back to 0. That's okay. Everything's all good here. Which means we're also going to need to change our camera back to 0 on the Y. And we're all fixed. All right, so that was a minor bug. The main thing here is we need this player to have his Z facing upwards there. That's going to be really important for stuff like shooting projectiles and movement and all that. Okay, so now that we're all fixed here, I'm gonna need to constrain all these. That's okay. Use gravity. Good, good, good. All right, cool. So now we're ready to begin start programming this player here. So go ahead and make a new folder here, just for organization's sake. New folder called scripts. And create a new C# script. I'm just gonna call it player controller. Go ahead and go in your player and drag that script onto the player. Make sure it goes on the player, not on the main camera, else you're going to have a little bit of issues here. And you should see player controller script in your inspector here. All right, perfect. So go ahead and double click this script and you'll start to see MonoDevelop open. Oops. Open it up on my different monitor here. Okay. So depending on if you've modified MonoDevelop before, it's probably going to open up with a white and bluish kind of color scheme if this is your first time opening it up. I prefer this color scheme because it's just easier on your eyes. If you want to change it, you can go to Tools, Options, and then right down here in Text Editor, you can go to Syntax Highlighting, and you can set it to Oblivion, and this is like the dark theme, or you can set it to whatever other theme you want. Okay, so with that out of the way, let's go ahead and get started. I'm going to zoom in here. So first we need to start detecting key presses, and then we'll move our player accordingly. We're going to need a couple variables here. Actually, we're only going to need one for now. First is going to be a public float. And let's name this speed. And we're going to set it equal to, let's just go with 1.0f right now. So I'm going to explain this a little bit. Public means that anything can access it. For a beginner right now in Unity, all public should mean to you is I can see it in the inspector. Notepad++, stop. So if we go to our player, since that's public, once this compiles, you just give it a second, you'll actually see it in the inspector. If this was a private variable, that means only this class can access that variable, and you won't see it in the inspector anymore. Bonk, it's gone. So we want to just keep that public for now because that's something we want to modify in the future maybe. All right, cool. Now float is the data type. It stands for floating point number, and that basically just means decimal point. This is useful for if you want stuff with floating point precision. So instead of 1, maybe you want 1.25 or 1.5 or maybe just 1.0. It gives you a lot more precision than an integer, and we'll talk about integers in a little bit when we're dealing with life. But for speed, you definitely want to be using a float. Now the speed right here, this could actually be anything you want it to be. It could be that if you want to, then that's extremely bad programming practice. But generally, you want to have a variable name that's relevant to what it's doing. So speed is going to be our player's speed. You don't have to do this, but this is, universal programming etiquette. You always want to begin your variables with a lowercase letter. And let's say I wanted a variable named speed control. You're going to be using something called camel case. You'll start with a lowercase, speed, and then you're going to start with an uppercase for your next letter, control. Just like that. But just for now, we're going to use speed. And then we're going to need our equal sign, and that assigns it a value right here. And it's going to be 1.0. Now, you have to keep in mind, there's a little quirk with floats. At any float, you're going to need to put F at the end of the value, or else it's going to spew an error. And if I do that and hit save, and look in the Unity console, you're going to see an error here, and it's going to say a double can't be a float. And a double is a different data type. It's pretty similar to a float, but usually floats are used in C# more than double. So let's go ahead and put that F there. So now that we've covered variables, let's go ahead and cover the update class. Update is called 60 times per second. Actually, no, it's called once per frame, so as many frames as being called as possible. Update will run. It's basically just a game loop. So this will keep running over and over and over and over and over again for the entirety of your program. So this is where you want to do checks and stuff. And this is where we're going to come to one of the most monumental, absolutely the most important part of any object-oriented, actually no, all programming languages, to be honest. If. This right here, this is programming. All programming revolves around Boolean logic, and if is at the heart of it. If is basically just checking for yes or no. There is no in between with if. It is a yes or no, a true and a false. So we need to be checking for a button press. We're going to say input. So we're checking for input, keyboards, joysticks, mice. Then we're going to need a component of input. We're going to say dot, say get key, and that's going to be checking for keys. Go ahead and put one more parenthesis. Now we're going to say, okay, which key are you looking for? Say key code. And since this is going to be forward, we're going to say keycode dot W. Go ahead and close that bracket there. Do it one more time just because it'll match up there with that ending if. All right, cool. So now we have an entire little if statement. So it's saying if the W key is being pressed down, okay, what should I do in that situation? So now on the next line, go ahead and put an opening bracket and a closing curly bracket. And inside here is the code that will execute every time that this is true. If this is false, it'll just skip over this code. All right, so now we're gonna need to give it a command to move our little player. So with object-oriented programming, you need to understand a pretty important part of it. It's object components. You have objects, which is our object here. That's our player. That's an object. everything in this inspector here is a component, and we modify these components to modify the object. So if I modify this transform component, it modifies the player object. So let's go ahead and get that transform component, and we're going to say game object with a lowercase g that refers to itself. That's an object. And we're going to say dot to get its component, transform, and now we're going to call a little function here, a method. It's going to be translate. Translate, there we go. It'll have a capital T right there. Now this is a function, so you can go ahead and hit parenthesis. It's going to be expecting a vector 3, so that's basically just 3 float values in one variable. But there's some pre-made vectors that'll be really useful for us. So let's say vector 3, and that's a data type. And you can say dot, let's go with forward, and that's a pre-made vector right there. All that really is I think it's I think that's all it is, and that's what that means. So you could technically make a new vector and put that in there and work the same way, but this is nice and easy for us. Now we're going to need a time comparison here, so we're going to need time dot delta time, and that just means the time between frame updates. We're also going to need to put in our speed here. And that's all we need, this line of code right here. So let's recap. If the W key is pressed down, execute this little line of code, which means it'll get the game object, game object, which is the object, that's our player. It'll get its transform, which is a component. Look, see, transform right here. And then translate it, which in math terms basically just means move. And that will make it go forward a little bit each frame with time.delta time, multiplied by our speed factor, which is 1, so it's going to be pretty slow. But we can actually go back to our script here in the inspector, and we can change that variable. Let's say 10. All right, perfect. I just pressed Control S here, and we're going to need to save our scene. Let's do that real quick before we play. Go ahead and right-click, create new folder. Scenes. Let's save our scene here. Save scene. Let's call it me. Perfect. So now you should see that little scene in there. So now that we're all saved, let's go ahead and look at our player. And if we hit play and hit the W key, he's moving. He can't move any other direction other than forward, but at least we have a little bit of, life and animation in there. Woo! Now he'll just keep going forward and fall off the edge, and he ain't gonna care. What we can do is we can just copy paste that code we made for every other key, and we can move him in any direction we want. And since he has a rigid body, he just falls with gravity, so he's gonna be going on forever because we never destroy him. But whatever. If we just hit play again, he's back. All right. So let's go ahead and go back to our code. Now what we can do is you can go ahead and select all of this, hit Control C, and then hit Control V, which is copy paste. Go ahead and do this 3 times. So we have 1 for each direction. Now I'm going to be doing something called commenting. You do 2 slashes, and basically what this means is the compiler will ignore anything that's in here. So what you can do is you can say this controls forward. So this means nothing to the compiler. It's just human readable text that you can use to, translate whatever you've made. So we have W, 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 W. So right now it can move forward at extreme paces, but that's not exactly what we want. Let's go W, A, S, and D, and this is the standard, key loadout, I guess, for most games. If you want to, you can change it to the arrow keys, but that's completely up to you. I'm just going to use WASD for now. So right now, if we ran this game, all it would do is make the cube go forward no matter what key you pressed. So A, this control left. And go ahead and copy paste our comments. This controls back, and this controls right. Perfect. And then let's go ahead and change our vector direction. So instead of vector 3 dot forward, you can say vector 3 dot left. Vector 3 back. Vector 3 right. Perfect. So now if we go ahead and compile, wait till that little spinny stops, we should have a fully moving character. Every direction. All right, cool. Now you'll notice, if you didn't have a rigid body on your character, that if he bumps into a wall hard enough, he might slip right through it. Fortunately, we did put a rigid body on here. A better way to do this would be a one-line change here. Instead of game object, we're going to use rigid body. Now you have to make sure that you did put a rigid body component on your player here. You should see rigid body. If you didn't, you can go to add component. But this is going to get the rigid body instead and move it based on the physics engine. So let's say rigid body, there we go. You can go ahead and copy and paste that for each one. This will just ensure that your character does not go through walls. He might clip a little bit, kind of like what you just saw there, since we do have a rigid body, but I'll just make sure that he doesn't just immediately translate through the wall. So if we bump our wall, yeah, we still got a little bit of jolting, but it's better. Okay, so, 1 second. Our player's moving. He's bumping into walls. We got a little starting area. And in the next episode, we're going to expand the playing area a little bit, and we're going to make a little button door puzzle. Nice and easy. So I'll see you in the next one. Thanks for watching. Bye.